Hey guys, so in this video I'll be talking us through z-scores. So I've briefly mentioned z-scores before, but I haven't looked at them in depth. So, a z-score. What a z-score is it tells us the number of standard deviations, tells us the number of standard deviations an observation is from the mean. So, if we remember, we had this average price of $2 for when I went out and sampled these prices of apples. I found the average price was $2, and this is our X bar, and we had this standard deviation, which we denoted as sigma. So if I come over to our prices of apples graph over here, I can mark down our X bar, and our X bar is always this middle line. It's where the mean is, it's where the very center of the normal distribution is. And to the right, we had numbers which were positive, standard deviations away from the mean. So if our average price was $2, our average price will be $2 and it'll be right in the center here. And to the right, we have numbers which are above $2, which are positive standard deviations away from the mean. So at this red marking, there would be X bar, which is the mean, plus 1 standard deviation, and that would be equal to $2.50. Down here, because of the properties of symmetry, we'd have our mean, which is X bar minus 1 standard deviation, at $1.50. Then we could have, at this red mark, we would have our mean plus 2 standard deviations, and that would be at the price of $3, which is just calculated as this $2 plus this 50 cents twice. And properties of symmetry, down this side we have our X bar minus these 2 standard deviations. It's minus because we're to the left of the mean, and that would just be $1. And then lastly, we've got our X bar plus 3 standard deviations, that would be $3.50. And our X bar, which is our mean, minus 3 standard deviations, would just be 50 cents. So we know that the z-score tells us the number of standard deviations an observation is from the mean. So it's pretty simple to work out the number of, or the z-scores for these first numbers, which I've drawn up here. So for this $2, it's at the mean, so there's no deviation from the mean. So the z-score will be 0. For this 1 standard deviation away observation, it's positive 1 standard deviations away, so the z-score will be 1. For this negative standard deviation, it will just be the opposite, so it's going to be negative 1. For 2 standard deviations, it's 2 standard deviations away from the mean when we go up, so it's positive 2 away, positive 2. The z-score is positive 2. And for the negative 2 standard deviations, the z-score is just negative 2. And for our 3 standard deviations above the mean, the z-score will be positive 3, and our 3 standard deviations below the mean, the z-score will be negative 3. So there are our basic z-scores. We got 0, 1 for 1 standard deviation, 2 for 2 standard deviations, 3 for 3, negative 1 for negative 1 standard deviations, negative 2 for negative 2 standard deviations, and negative 3 for negative 3 standard deviations. And that's pretty easy to work out. But what if we wanted to know how many standard deviations away from the mean, say an observation of $3.49 is? We can't just look at our table, our z-scores, and say it's 3 standard deviations away, because $3.49 would fall around about here. So this would be $3.49. But that's not quite 3 standard deviations away, so we know it's less than 3. So it's going to be less than 3, which I'll denote with this less than 3. But it's also going to be more than 2 standard deviations, because it's somewhere in between. So it's going to be more than 2 and less than 3 standard deviations away. but we're not quite sure. So we use this method to standardize or find a z-score. And I'm going to show you how to do that just now. So what we actually do to find this z-score is we can use a handy formula. And it's a very intuitive explanation, but for our purposes we really only need to know what the formula is. So to calculate this z-score, and I'll just make some room here. So we want to calculate this z-score. So in order to calculate this z-score, we want to calculate it for this observation of $3.49. And I'll call this z-score value x. And note I've called it this x. And I know that we have this average price of $2. So our average price is $2, and that is equal to our x bar. So the way we work out this z-score is that we basically take our observation of x, so we take our $3.49, and we want to know how far away from this mean value we are. So the z-score is how far away from the mean value we are. So what we do is we take away our mean value. So we take this mean value away from our x observation. And that basically gives us this distance here. So that's going to give us the distance from this value to the mean. And that is x take, that is going to be this x take the x bar, which is the mean. And that gives us this distance here. But we then want to put it into a z-score value. And we want to know how many standard deviations away we are. So what we do then is we divide it by the value of a standard deviation. So from up here in purple, you've got the value of a standard deviation is just equal to sigma. And this sigma was equal to 50 cents. So to calculate this z-score, we use this formula. This x observation minus the mean divided by the standard deviation. And this gives us the z-score. So if we then just plug in our numbers, so we have $3.49, we have $3.49, and we take away our value for the mean, which is $2, and we then divide it by this value of the standard deviation, which is 50 cents, we can see that we have $3.49 minus $2 divided by 0.5, and if we solve all of that out, it will give us a z-score value of 2.98. So our standardized value is 2.98. What we can then do is have a look at how this compares to our observation on our price of apples curve versus our standardized curve. If we were to just plot this down, and we were to say trace this $3.49 down, we'd find that it would, or we would expect it to be just less than 3 standard deviations away, because it's just less than 3 standard deviations way up here. So because it's come out to be 2.98 standard deviations, we know that the z-score for $3.49 is going to be 2.98. So that is how we calculate a z-score, and that's what it is. It's the number of standard deviations away from the mean. We could then apply this to some questions, and I'll show you how to do that in some further examples. Thanks, guys.